In this video, we're going to look at some examples dealing with amortized loans. So just as a reminder, here's the formula for an amortized loan below here. P stands for the present value or the amount that you're borrowing. R is your monthly payment or regular payment if it's not monthly. Little r is your rate in decimal form. M is the number of compounding periods per year. And T is time, always in years. All right, so here's our first example. What's the monthly payment if you borrow $45,000 in an amortized loan with an annual interest rate of 4.8% compounded monthly, and the term of the loan is 10 years? All right, so we are told that it's an amortized loan, so that means we want to use the formula P equals R times 1 minus 1 plus R over M to the negative MT all divided by R over M. And let's identify what we know. So we're borrowing $45,000, that's our capital P. We have an annual interest rate of 4.8%, so little r is 0.048. Compounded monthly, so M is 12. And the term of the loan, is 10 years, so T is 10. All right, let's plug everything in. So I have 45,000. I'm going to leave some space. Well, here we go. 45,000 equals R. We don't know R, right? What is the monthly payment? Times 1 minus 1 plus 0.048 divided by 12. To the negative 12 times 10 all over 0.048 divided by 12. All right, we need to solve for R. R is multiplied by this big fraction. So to get rid of a fraction that's multiplied, we're going to multiply both sides by the reciprocal of that fraction. So I'm going to multiply both sides by 0.048 over 12 over 1 minus 1 plus 0.048 over 12 to the negative 120. See if I can fit that in here. 0.048 over 12 over 1 minus 1 plus 0.048 over 12 to the negative 120. Okay, so on the right, everything cancels, and I just have R. And on the left, I'm just going to plug this product here in. So in your calculator, you're going to type 45,000, parentheses, fraction, 0.048 divided by 12 on top. Then scroll to the bottom, 1 minus, parentheses, 1 plus 0.048 divided by 12 to the, make sure you get the negative 120 in the exponent. Scroll to the right and close that last parenthesis and hit enter. I got 472.91. So your monthly payment on this loan will be $472.91. Okay. A $50,000 amortized loan at 3.28% interest for 15 years has a monthly payment of $352.06. Fill in the first 3 lines of an amortization schedule below. So an amortization schedule is just a table that shows you what happens each month with your loan. All right, so your payment every month is the payment that you've been given. So my payment here is $352.06. So I'm going to go ahead and fill that in for each month. Oops. Now your interest, when we calculate the interest by month, we can use simple interest. So interest is I equals PRT here, where P is the current balance of your loan, R is the rate, and T, remember, is time in years. And so if we're going by months, it's been 1/12 of a year. So your T, when you're calculating interest each month, will be 1/12. So let's just look at month 1. So in month 1, interest is PRT, where my P is the current balance of the loan. The current balance of the loan is what we started with, so $50,000. My rate is 3.28%, so in decimal form, it's 0.0328. And like I said, time is 1/12. So go ahead and type that into your calculator, and you should get 136.67. So in month 1, the interest is 136.67. Now when you pay your loan, you pay this $350.06, and they're first going to take out the interest. So they're going to take out $136.67 to pay for the interest. What's left of your payment goes towards principal. So your payment to principal is always your payment minus interest. Okay? So in this case, my payment to principal is my payment, $352.06 minus 136.67. So type that into your calculator, and you should get 215.39. So $215.39 of that payment is going towards reducing the balance of your loan. Now, I like to write up here the current balance of the loan, or the starting balance of the loan, was $50,000. Your new balance is always going to be the current balance minus the payment to principal. Okay, so let's say the previous balance minus payment to principal. Okay. All right, so in this case, my previous balance is the $50,000. That's what I'm starting with. Minus, I've paid $215.39 towards reducing that. Okay, so what I get here is $49,784.61. All right, and that's month 1. Now in month 2, we follow the same rules for calculating interest, payment to principal, and new balance, but our current balance is now the balance listed here on the right after month 1. All right, so let me erase here, and we'll start over in month 2. Oops. Let's do month 2 in blue. All right, so interest is PRT, where now my P is the balance from month 1, so $49,784.61. My rate is still 0.0328, and time is always 1/12. Okay, so plug that into your calculator, and you should get 136.08. I've typo here. 136.08. So notice my interest has gone down a little bit, but it's gone down, and it should. Every month the amount that you're paying in interest should go down, and so your payment to principal should go up. So my payment to principal now is my payment, $352.06 minus the interest, 136.08. And so I get 215.98 here. And finally, the new balance is going to be the previous balance. So that's 784.61 minus the payment to principal, which was 215.98. So plugging that into your calculator, you should get 49,568.63. All right, so we're going to try this for one more month, month 3. So let me erase the work for month 2. Let's do month 3 in green. Okay, so interest is PRT. Our new principal is the principal that we found at the end of month 2. So 49,568.63 times 0.0328 times 1 over 12 is 135.49. So again, interest is going down, 135.49. Our payment to principal is going to be 352.06 minus this 135.49. That's 216.57. And finally, the new balance on the loan, I'm going to take the balance in month 2, so 49,568.63 minus my payment to principal, 216.57. And I get 49352.06. Now this is a 30-year, oh no, it's a 15-year loan, sorry. So you would want to be able to do this for 15 times 12 months, right? When you take out a loan, they will provide you with this schedule filled out for the entire term of the loan, assuming that you make this minimum payment. In practice, we will only compute the first few months just so that you can get a picture of what's happening here. All right, let's look at one last example. How large a mortgage can you afford if you can afford to pay $950 a month and you've been offered a 30-year mortgage with an interest rate of 4.235%? All right, so a mortgage is a type of amortized loan, so we want to use the amortized loan formula. Let me switch my pen back to a color that's easier to read. So we have P equals R times 1 minus 1 plus R over M to the negative MT all over R over M. And what do we know? We know how much we can pay, $950 a month. That's my R, capital R. It's a 30-year mortgage, so T is 30. We're making monthly payments, so M is 12. And I've been offered a loan at a rate of 4.235%, so little r is 0.04325. All right, so we just need to plug everything in. P equals 950 times 1 minus 1 plus 0.04325 over 12 to the negative 12 times 30, all divided by 0.04325 over 12. Now we're solving for P. On the right-hand side, we don't have any variables, so we just need to plug this into our calculator. Make sure you get these big parentheses here. Make sure you don't miss the negative in the exponent, and make sure that this multiplication in your exponent is in parentheses. All right, so go ahead and type that in. what you should get is 193,458.20. So you can afford to take out a loan worth $193,458.20. All right, we will look at some more complicated problems with mortgages later and amortized loans, but this is a good place to start.